Alright, so here we have a motion problem. So the first thing I want to do is create a table which will have a distance column, a rate column, and a time column. And this problem deals with an airplane flying with the wind and against the wind. So one row I will title with the wind. This will be with the wind. And the other row will be against the wind. And now I want to work on filling in the 6 boxes. We're told that the distance that the airplane flies with the wind is 460 miles. And then we're told that against the wind, the airplane flies 310 miles. The goal of the problem is to figure out the speed of the airplane. So I'm going to let x represent the airplane speed. You know, x is going to represent what we want to find. When the airplane goes with the wind speeds up things. The rate of travel with the wind will be the airplane speed plus the wind. But the rate that the airplane travels against the wind will be the capability of the airplane, x, minus the wind, right? The wind slows the airplane down. Now I got to get the time box. Well, distance equals rate times time. And if I divide both sides by r, I see that time is equal to distance divided by rate. So the time box will be the distance box divided by the rate box. So it'll be 460 divided by x plus 30. And the other time box can be modeled by 310 over x minus 30. Once we have all the boxes filled in, the next thing we do is create an equation. Notice that it says that the airplane flies with the wind and against the wind in the same length of time. So that means that this expression and this expression have to be the same. You know, we can set them equal to one another. We're told that the time with the wind and against the wind is the same. So I can use that to create the equation. I can go 460 over x plus 30 equals 310 over x minus 30. And to solve this equation, we could cross multiply, or we can multiply by the common denominator. It doesn't matter. If the common denominator would be x plus 30 times x minus 30. And when I multiply that by the left side, the x plus 30's cancel out, leaving us with 460 times x minus 30. And when I multiply the common denominator by the right side, the x minus 30's cancel out, leaving us with 310 times x plus 30. And now we just finish up this equation so we can distribute. First we distribute to remove the parentheses, so we have 460x minus, now I'm going to use my calculator, 460 times 30. So 460 times 30 looks like it's 13,800 equals 310x plus 310 times 30. Looks like it's 9,300. If I subtract 310x from the 460x, that would be 150x. And then I'm going to add 13,800 to both sides. Let's see, 9,300 plus 13,800. So with the help of my calculator, I see it's 23,100. And now we just divide. So 23,100 divided by 150 looks like it's 154. So there we have the speed of the airplane, 154 miles per hour. All right, here we have, let's see, looks like we have a working together problem. 2 pumps can fill a water tank in 45 minutes when they work together. The second pump, when it works alone, takes 3 times longer than the first to fill the tank. How long does it take for the first pump to fill the tank? Okay, so we have 2 pumps. So we have what I'll call the first pump, and then we have a second pump, and then we have the two pumps working together. When the two pumps work together, it says it takes 45 minutes. The second pump takes 3 times longer than the first pump to fill the tank. So what I'll do is I'll let the first pump takes X minutes, and we're told that the second pump takes 3 times longer than the first. So that means the second pump can be mathematically modeled. The time it takes is 3x. And anytime we have a working together problem, we can go 1 over the time for the first pump plus 1 over the time for the second pump equals 1 over the together time. What we're doing is we're adding the work rates of the first two pumps together, and that'll equal the together work rate. Now it's just a matter of solving this equation. To solve this equation, we can multiply through by the common denominator to get rid of the fractions, which would be 45x. 45 will take care of the 3 and the 45, and I need an x to cancel out the x's. When we multiply 45x by 1 over x, the x's cancel, leaving me with 45 times 1, so that's 45. And then when I multiply the common denominator by the next expression, the x's cancel again. 3 goes into 45 15 times, and 15 times 1 is 15. And finally, when I multiply this by the last one, the 45's cancel out, leaving us with x times 1. And so I see that 60 is equal to x. So the question was, how long does it take the first pump to fill the tank? That was just x, so 60 minutes. 60 minutes is the answer. It looks like it would take 3 times 60, or 180 minutes for the second pump to work alone, but it looks like we're not asked that. 60 minutes is how long it would take the first pump. Alright, so I'm going to let F represent the force. M is going to be the mass. And I'll let S represent the speed of the car. We're told that the force varies jointly. Recall that a joint variation is like y equals kxz. That means y varies jointly with x and z. We're told that the force varies jointly with the mass and square of the speed of the car. Now I got to find k. It looks like we're told that a passenger experiences a force of 259.2 newtons. So that means I'll plug 259.2 in for F. When the car is moving at a speed of 60 kilometers per hour and the passenger has a mass of 80 kilograms. So that means the mass is 80. I'll plug 80 in for M, and the speed is 60. And now I got to use my calculator to solve for K. So 259.2 divided by 80 divided by 60 squared. 60 squared is 3,600. So I went ahead and divided both sides by 80, and I divided both sides by 60 squared. And so using my calculator, 259.2 divided by 80 divided by 3,600 is K equals point. Looks like my calculator put this in scientific notation. It looks like it's 0.0009. Right. I'm just going to check that. If I take 0.0009, which is my value of K, and I multiply that by 80, and I multiply that by 60 squared, I get 259.2, which is what I wanted. All right, so that's the correct value of K. Once we have K, we plug it back into the formula, And so we have F equals 0.0009 ms squared. That's the answer to, this is the answer to part A. That's the general formula that describes the variation. We can use that formula to answer some questions. It says, find the force a passenger experiences when the car is moving at 70 kilometers per hour and the passenger has a mass of 40 kilograms. So we just plug those numbers in. So we're told that the mass of the passenger is 40 and the speed is 70. And so I'll use my calculator. 70 squared times 40 times 0.0009 is 176.4 with the help of my calculator. And the force is in newtons, it looks like. And so there's the answer to part B.